Super Heavy buckles during testing. New Glenn is getting a huge upgrade. Starliner will try being a cargo ship, and a different Comet Atlas breaks up. All this and more in this week's Space Bites. So SpaceX completed its round of testing with the V2 Starship, and this is the one where we saw the Super Heavy booster recovery. We saw Starship fly to orbit, but then return through the atmosphere and soft land in the ocean. V3 is the next big iteration, and we've been everything's been leading up to this. And with V3, we're gonna see an upgraded booster, more powerful rockets, and we're hoping to see that full reuse of the Starship upper stage. But the rollout is having a few problems. And so last week we saw the rollout of Booster 18, and this is one of the new potential upgraded Super Heavy boosters. Now, this version didn't have any engines on board. They didn't put any propellant on board. They were doing tests of its structural system, and the rocket crumpled. Now, according to SpaceX, they were testing its propellant systems and structural strength, and they said it suffered an anomaly during the gas system pressure testing. The test that they were hoping to find out, can they find the limits of its structure? They found it, it crumpled, there's a problem, and that booster is probably a write-off. That'll buff right out. Some new paint, it should be fine. That'll fly. And so we're gonna have to see what happens next for them to continue with their testing. So no date for when we're gonna see Starship return to launch. And a shout out to Lab Padre and Starship Gazer, who have been watching the facility and caught images of this damage right away. And now on to another heavy lift rocket platform, and that is New Glenn from Blue Origin. Now, we finally saw the launch of the New Glenn rocket from Blue Origin, and that was amazing. And this was with the older version of New Glenn, the 7X2. It has 7 engines on the first stage and then 2 engines on the upper stage. Like SpaceX, Blue Origin is planning to offer an upgraded version of New Glenn. And so the new one, they're going to be calling the 9x4. 9 times 4? 9x4? Anyway, 9 upgraded engines on the first stage and then 4 upgraded engines on the upper stage. So it's also going to have a larger 8.7 meter fairing. So what does this give us? So this gives you 70% more cargo capacity with this larger fairing. It's going to give you 50% more thrust on the first stage and 100% more thrust on the upper stage. And so this should allow New Glenn to carry 70 metric tons to low Earth orbit or 20 metric tons to a translunar orbit. And this is a key part of Blue Origin's plans to be able to send cargo to the moon. They're going to be handling an upcoming lunar lander, and so they want to be able to deliver a lot of cargo to the surface of the moon. And the picture that I really like is to see this comparison of the original New Glenn next to the Saturn V rocket and then the upgraded New Glenn version. And you can see that, Saturn V is an adorable little rocket compared to this next range. And like, obviously, Blue Origin didn't put the Starship on that picture, which would look even bigger. And so we're in this new era of these giant rockets, but we still need to see this become a much more repeatable, dependable, continuous thing that's happening. So we're sort of at the early stages of this super heavy lift, reusable era. And we've got a story about this from Matt Williams on Universe Today. All right, I've got some bad news. Comet Atlas just broke up. Now, not that 3i Atlas, but Comet Atlas. And that's because there's a ton of Comet Atlases and a ton of asteroid atlases, and this is all thanks to the Asteroid Terrestrial Impact Last Alert System, which is called ATLAS. And so when you discover a comet, you get to name the comet after yourself. And in this case, the comets are named after this robotic telescope that's in Chile called ATLAS. Now, ATLAS's job is to find asteroids and comets that are on a potential impact with Earth to give us this last-minute discovery of this object. It's scanning the parts of the sky where asteroids can hide and be sneaky, and we won't be able to detect them until just a few days, weeks before they actually impact us. And so ATLAS is scanning the sky, finding these things, and it has found a lot of objects. And so this other object is C2025 K1 ATLAS. And this is a comet, just a regular comet that people have been watching, but last week it broke up. It had this obvious brightening, and then even people with smaller backyard telescopes were able to detect 3 distinct blobs in this comet. And this happens very regularly when comets get relatively close to the sun. They experience a lot of tidal forces. Comets are not these solid balls of rock or metal or whatever. They're these loose amalgamations of ice and dust and rock and metal and soot and other material and other volatiles. And they are experiencing a lot of outgassing, and the thing is under constant pressure, and as it gets close to the sun or close to, say, a planet, like what happened with Comet Shoemaker-Levy 9, it gets torn apart and you get this string of objects that then are now become independent comets from each other. And that's what happened to K1 Atlas, but is not going to happen to 3I Atlas. And speaking of 3I Atlas, we talked about last week about how a lot of various spacecraft all came together to observe 3I Atlas as it made its closest approach to Mars. We had the ExoMars mission from the European Space Agency, we had the Tianwen mission from China, and we had several spacecraft from NASA, particularly the Mars Reconnaissance Orbiter. And so during this closest approach to Mars, it's about 0.3 AU, we got all of these spacecraft attempting to make observations of the comet. Now, the pictures themselves were underwhelming, and that's not surprising because you've got this spacecraft camera that's designed to look down at the very bright surface of Mars, trying to then look at a faint object in space. And the object is moving very quickly, and the spacecraft is moving very quickly in orbit around Mars, about 15,000 kilometers per hour. And so this was an enormous technical challenge for people to be able to try and resolve this comet while the spacecraft was orbiting Mars. But they were able to resolve it, and they were able to chart its position over time. And this is really important because whenever we have these objects coming through the solar system, you predict its future trajectory based on the observations that you're able to make. The more accurate observations you make, the better you can calculate what's going to happen to it in the future. Now, with 3I Atlas, it's no big deal, right? It already went past the sun. It's going to come within a couple of AU of the Earth, and then it's going to fly off into the cosmos again. But if there are other objects that are on a potentially threatening trajectory, maybe something that could strike the Earth, and especially these comets, right? They're very dangerous. They can come out of nowhere, and this has happened in the past. It's almost inevitably going to happen in the future. And to be able to chart the position, the trajectory of these objects with precision, this is important. And it could be that those spacecraft orbiting Mars or Jupiter or Pluto will give us that first view and give us those first measurements that will allow us to know whether we're dealing with a dangerous object or something that we can just enjoy for the show. We've got a story about this from Matt Williams on Universe Today. Shortly after the solar system formed, there were a lot of planets, more planets than we have today. And it's believed that just within about 100 million years after the solar system formation, two of those planets collided, Earth and a Mars-sized object known as Theia. The greatest evidence that this collision happened was because of the moon. When the Apollo astronauts went to the moon, they found rocks on the surface of the moon that showed the composition of the moon is very similar to the composition of the Earth. The moon was once part of the Earth. How do you get a moon-sized blob orbiting around the Earth? You hit it with something big. In this case, you hit it with something like the size of Mars. But the question has always been, where did this thing come from? Was it something that was in the outer solar system that was hurled into the inner solar system by some three-body interaction with Jupiter, say? Or was it something that was always in the inner solar system? And so there are remnants of both Earth and Theia inside the Earth, and there are remnants in the moon as well. So scientists were looking at the chemical composition of the moon rocks returned from the Apollo missions, and they were able to detect the composition of the metal of Theia, be able to identify which is Theia, which is Earth, and be able to find that, in fact, the original composition of Theia was very similar to the Earth, similar kinds of iron and titanium and aluminum and other heavier metals. And so that indicates that Theia probably formed relatively close to the sun. In fact, probably closer to the sun than the Earth did. And so what this means is that, like, before the collision happened, Theia was a Mars-sized object in orbit around the sun, a little closer to the sun than the Earth, and that the constant interactions between their gravity caused it to drift outward, and that Earth and this planet collided, and that's what created the moon. We've got more about this from Matt Williams. So do you remember Starliner? Back in 2014, NASA awarded contracts to providers to bring astronauts to the International Space Station. They awarded a contract to SpaceX and to Boeing. And so with SpaceX, we got Crew Dragon. And obviously this has worked well. We've had a bunch of missions successfully go to the International Space Station carrying astronauts. For Boeing, it was the Starliner. And so far, we've only seen one successful test launch with Starliner, and there were enough problems with the capsule that NASA decided not to bring the astronauts home on their capsule and instead used a Crew Dragon to bring them back home. And so they spent several months on board the station waiting for their return home to be ready. So this is a problem, and we got an announcement this week that NASA and Boeing are revising their contract. And so instead of Boeing providing 6 launches of astronauts to the ISS, they're going to be doing a cargo launch next. And so in probably April 2026, they're going to fill the Starliner with cargo, they're going to send it to the station, and if that works, then 3 more launches for astronauts after that, before we reach the end of the life for the International Space Station. So hopefully, the next launch for Starliner will be successful with cargo, and then that will give everybody enough confidence that they can use this thing for people after that. So there's been a serious mishap at the Baikonur Cosmodrome after the most recent Soyuz launch. So this happened on November 27th, just a couple of days ago, where the new Soyuz MS-28 lifted off from the Baikonur Cosmodrome, and the launch went well, but images of the facility afterwards showed that the launch gantry, the thing that holds the rocket in place, collapsed, and it's a mess. Twisted metal, and this is not a place that's going to be launching rockets for a while. Now, we don't know the official reason why this happened, but clearly the structure collapsed down into the area where the flame duct happens underneath the pad. According to Roscosmos, they say they'll be able to get it working again. They've got all the spare parts. It'll take them a little while. We don't know. But people who are looking at this think it's, we're looking at years away before this facility is going to be able to launch rockets again. And this is Russia's only way to be able to launch astronauts to the International Space Station. So unless something magical happens, Russia will no longer be capable of launching humans up to the station. I don't know what the implications of this are going to be. Like, is it they're going to be launching their astronauts on board US rockets from here on out? They're going to be no more Russians on board the station? The Chinese are going to take over? I don't really know. So we'll have to stay tuned to see what happens. But this is a big problem for the Russian space agency. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was this new possibility that dark energy doesn't exist. This is the first time we had 3 Atlas on the list and it didn't win. So thank you everybody who voted last week. Now, within a few minutes, we will post this week's episode into the post tab on our YouTube channel. So you can go there and find it, or all of the past polls, and vote a whole bunch, and then that will just train the algorithm. But you should also subscribe to the channel, click on the notifications bell, and that will give you more updates on a regular basis. So scientists think they found evidence of lightning on Mars for the first time. Now, that sounds really exciting, and this is very downscaled lightning. So what happened was that the Perseverance rover is equipped with a microphone. And during an event where there was a dust devil swirling around Perseverance, they detected the electromagnetic signature as well as the acoustic sounds of static electricity discharges. The equivalent of Perseverance touched the doorknob after walking on the carpet. This static discharge is caused by the friction of all of the particles that are interacting inside this dust devil. And we know the dust on Mars is electrostatically charged. We see how it coats the outside of various equipment on Mars, renders their solar panels unusable, and how often as these dust devils come by various solar panel spacecraft, it can clear them off again. So there's this electromagnetic charge that's going on inside these dust devils. But the fact that they actually detected the discharge on Perseverance was quite exciting. And so if you sort of scale and extrapolate this idea, then there could be sort of larger electrical discharges happening on Mars. And that when these discharges happen, they can break apart the chemicals in the Martian atmosphere and release free oxygen that can oxidize and gobble up other kinds of chemicals. And so this might be an explanation for why, although there has been methane detected in the atmosphere of Mars, it hasn't been around for very long. It's detected and then it disappears again. And it could be that you're getting the static electricity, it's breaking apart free oxygen. The oxygen is finding its way to the methane and then gobbling it up, and so making it not detectable anymore. So it's interesting, we're not seeing like full-on lightning storms in Mars yet, but there is more static electricity going on in the atmosphere than we thought. It's time for a couple of pictures. This first picture was taken by the Sophia telescope. This is this really cool flying infrared observatory that NASA was operating. It's no longer operational because of Webb, but still it did a lot of really incredible infrared observations. And you're looking at the Cygnus X star-forming region, which is located about 4,600 light years away from us. And it contains a lot of cold molecular gas, one of the largest clouds nearby that we know of. And this is where new stars form. And you're seeing this giant ring, this bubble that is being blown out by a very hot star. It's classified as a B-type star, and they're some of the hottest known. And we see these kinds of bubbles in other molecular clouds. You get this star forming, it sends out this powerful radiation that pushes away additional material, so it can't get added to the mass of the star. And there's probably about 1,000 times the mass of the sun in this bubble, this ring that is growing around the star. Often these bubbles are very spherical, and this one is very flattened, and astronomers think that in fact the star is rotating very quickly, is releasing a lot of material along its equator that is flattening out the bubble, and it almost like caused it to pop. And so we're seeing this from our perspective. It's a very cool picture. We've got a story about this from Evan Goff. And then here is another image, and this one comes from Webb. Actually, the first picture I want to show you comes from the European Southern Observatory's Very Large Telescope, and it shows this really strange, almost like pinwheel structure in space. And we knew that this is caused by two Wolf-Rayet stars, which are gigantic stars orbiting around each other. They take a few centuries to go around each other. And then there's a third star that is orbiting around them, also a massive star, but it takes about 10,000 years to complete an orbit around the binary stars. And astronomers weren't sure that that third star was part of this binary pair because it's orbiting so far away. And so you see this crazy pinwheel structure, almost like serpent-like eating its own tail structure. But then in the Webb images, you get this much wider scale look of the whole area, and you can see that this small shape is repeated multiple times at multiple scales. And so this is some kind of interaction that's been happening between these stars for a very long time, that one or the other of the stars in the center is letting off a release of its outer layers, that it's drifting outward. Then this third star is plowing through this material and whirling it up and shaping it into this structure. And in fact, there's 4 versions of this shells in this larger picture. And of course, all of these stars, they're giant, they're hot, they're burning through the material quickly, and they're doomed, and they're going to explode as supernovae and probably leave black holes behind. Got a great story from Evan Goff about this. I love this kind of a mystery where you have this first picture taken by one of the smaller ground-based telescopes. Smaller, he says, 4 giant telescopes, 8.5 meters across, linked up into a single interferometer, but still. And then you have James Webb, which just takes everything to the next level. And these are the kinds of improvements that we were really hoping to see with James Webb. And we get little bits and pieces of it here and there. Now, there's a handful of stories here in Spaceflight. This is just a fraction of all of the stories that we're covering over on Universe Today. 30 to 40 stories every week. And obviously that's a lot. You want it in one place. You can sort of browse through and see everything that's happening in space this week. And that is a weekly email newsletter that I write. At the end of the week on Fridays, I gather all of the stories that we covered on Universe Today. I write every single word. There's no ads. It's completely free. Go to universetoday.com/newsletter to sign up. All right, like I said, I want to talk a bit about sort of how we do our journalism over on Universe Today. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradon, Chuck Hawkins, Commander Bailock, Sign Nielsen, Dark Finga, Dave Verbow, David Giltonen, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Matter, Jim Burke, Jordan Young, Josh Schultz, Marcel Spitz, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Robach, Rank Haidu, Richard Williams, Sean Sargent, Stephen Fowler-Menley, Team 49, Telescopes Canada, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. Now, as you know, I'm still on the road in Thailand. So now I'm in the city of Krabi, which is in southern Thailand, and recording from another hotel room. But this is the view off of our balcony, which is pretty cool. These giant mountains all around us. So it's very beautiful here in southern Thailand. So it's been a very busy week. You know, I've been doing Universe Today work from hotel rooms and the airports and the backs of rideshare vehicles. You know, and it sort of made me think about how I'd like to sort of talk more about like how we do our work at Universe Today, how we are finding stories, and sort of how our work compares to other places you might look for space news. I mentioned a couple of weeks ago during the government shutdown, sort of how rough it was for us to be journalists and not have NASA as a source. Required us to dig very deep. But just like in general, we dig very deep. We have a dedicated team of journalists, and they are, you know, we have a salary to pay everybody. And so everybody just keeps working at kind of the regular rate. So the way this works is that I do a lot of the story finding for the entire team at Universe Today. So I have about 1,000 sources on my RSS reader. That is, you know, they're not all updating every single day. So, you know, every day we get a few hundred that are updating. And then I put this into a content management system that then all of the writers can go through and then claim the stories that they want. And there's times when, like yesterday, I think I put 20 stories into the system and that the writers only grab maybe 8 or 9 out of that list. But then other days I only find 3. And so, you know, some weeks are huge, some weeks are small. When there's a lot of news, then we're kind of covering the same stuff that other people are covering. But when there isn't a lot of news, then we have this really deep archive of interesting stories, a lot of science papers that are going to take more work for the writers, but it's very satisfying to me as the publisher of Universe Today, because a lot of the stories that we have on the site, nobody else has, you know. I found it on Archive, or I found this really interesting paper that someone had written in this obscure aerospace journal, and we were able to cover it, and nobody else does. And then you can see other people reprinting our material, because everything is a Creative Commons 4.0 license for us, so you're free to use our material for anything you like. And so we see a lot of other websites that are just replicating our material, just copy pasting it, which is totally fine by me. Put ads on it, I don't care. So that's how we work. Some weeks you're going to see very similar stories from us to what other people are covering, because it's obvious these are the big stories of the week. And then other times, everything we're talking about is unique to Universe Today, and that feels very satisfying to me. All right, so I hope that gave you a little bit of an idea of behind the scenes, and we'll see you next time.